Voilà, là, encore du. Hein?
Hi guys, good morning. Can you hear me?
Yes,
Yes,
sir.
Paul?
Yes, Professor. Good morning.
Good morning. Yeah, we're gonna wait for another few minutes till people join the meeting, and then we're gonna start soon. So, meanwhile, if you have any question, please let me know. I see you guys went to lessons lab, and 50% of you guys finished the lesson lab 1, and 13% of you guys did lesson lab 2 before even we give the course for that. So that's congratulations to those guys who studied before the class. So that's great. Very good.
Excuse me, sir.
Yeah.
Where can I see my grades of the labs and lessons?
You have to go to Vereta, right? The secure.vereta.com.
Yeah.
And basically you log in with your credential, and then you see your lesson and labs in that platform. Okay. See your course.
No,
your course. Yeah.
I am talking about, sir, grades.
The grades.
Professor, I think like he's talking about like after giving the exam in VETA, like we'll be able to see our grades in the blackboard.
You should be able to see what's your score in the platform. If you don't see it, probably you can ask Reta, right? So is what's you can't see your grade in the platform?
Professor, I was able to see the grade after finishing my exam in the VETA, but like after that, I was searching for the grade in the Blackboard platform.
Oh, in Blackboard. So I haven't imported yet. So yes, sure. Yeah, you don't have it in Blackboard yet. So I will import in a couple of weeks. So you only can see it right now. You can only see it in Vereta, but in every couple of weeks I will import it to Blackboard. So I haven't imported yet. That's right. So you don't see it in Blackboard yet. So
understood. And Professor, another thing, I was searching for the recorded video from our first class, but there was no video that I didn't found.
Yes, unfortunately, I forgot to push the record button at the beginning of the session. So this one I already recording it. So unfortunately, like the first class, I forgot to push the record button. So is right now this one is recording, as you can see it on the top left.
Yeah.
Yeah. So from this one, it's gonna be recording. So sorry for that. So. All right. So. I think we're gonna start. Still, we have 15 people missing, but we can start, and then if they join, we can add them to the meeting. So, okay. All right. So I'm gonna share my screen right now. Do you see it? The PowerPoint?
Yes, Professor.
Yes.
All right. Sounds good. Yeah.
That's clear.
All right. So in this course, we're gonna talk about simple interest rate and also compound interest rate. So this PowerPoint is all about simple interest rate. So what's this and the calculating of the amount of simple interest. So what is interest? So interest basically is the money which you basically, if you put the money in the bank, okay, you borrow the money in the bank or invest the money in your bank is going to give you some interest, okay? And interest is based on the money, based on the amount of money you put in the bank and the interest rate. So interest, you can basically either invest the money to the bank and you get the interest, or bank can lend you money. So the most obvious part is basically the credit card, right? So the credit card is the basically is one example of basically interest. So you basically bank give you a credit card with like 19% interest or 20% interest or something like that. So it means that any money you spend from that card, like let's say $1,000 you spend on the card, you have to pay 19% interest by the end of the year. So it means that $190. If you just keep that money, spend it, so you basically had to pay $190 a year for that money. Okay. So it can be either borrowing money, which is like line of credit or credit card and all those things, or maybe mortgage or whatever, or it can be investing money. You can also basically put your money in the bank and receive interest. So for example, in GIC account right now is very popular. They pay you 4% interest rate. So it can be the other way as well. So how do you calculate the interest, basically interest, the amount of interest, okay? The amount of interest that you received after a year or after a period of time, depending on what the period of time and interest rate, is the principal amount, the actual amount you put in the bank, multiplied by R, which is a simple interest rate, which is the rate at which the principal is borrowed or invested. It is expressed as the percent of the given for a given period of time, and time period, the period of time for which the principal amount is borrowed or invested, during which interest is charged or earned. So basically, that's the simple equation for interest. You have to note that the unit for R and unit for T has to be the same. So if interest rate is charged annually, then T need to be in year. If interest rate charged monthly, this has to be months. If it's daily, it has to be daily. Okay, these two has to have the same unit. So R and T has to have the same unit. Okay. Okay, so for example, we have an example here. For example, if you consider $1,000 invested at an interest rate of 10% per annum, okay? After 1 year of investing, obviously you have 10% of $1,000 added to basically $1,000, which is going to be total interest rate earned is $100, 10% of $1,000. After 2 years of investing, again, $1,000 multiplied by 10%, plus $1,000 multiplied by 10%, which for the second year. This is for first year. This is second year. It's going to be $200, and so basically interest rate for 2 years is going to be $200, and after 2 years of investing, the interest rate is going to be $300. Okay, so basically the principal amount multiplied by interest rate multiplied by number of year, okay, is how the simple interest is calculated. Okay, so after 2 years of investing, the total is going to be interest is going to be $1,000 by 10% by T year. Okay, so that's how it calculated. Basically, the principal amount multiplied by interest rate per annum multiplied by number of years. Okay, but interest rate sometimes can be per month. Okay, so it can be per month, can be per day. So you have to be very careful about that. So you have to read the question properly to be able to answer it. Okay. All right. Roger borrowed $3,200 at the simple interest rate of 8.6% per annum. How much interest was he charged at the end of 1 year? Okay. That's pretty simple. So you have basically the principal amount, you have interest rate, and you have 1 year at the end of 1 year. Okay, how much is going to be? So it's going to be this guy multiplied by this guy multiplied by 1, right? So this is per annum, so per year. But you have to be very careful. This is 8.6%. So you need to convert this guy to the actual number. As I said the other time, the percent is just for demonstration. If you wanna convert it to an actual number, you have to divide by 8.6 divided by 100. Okay. So as I said, the principal is 3,200. R is 8.6% per annum, which is going to be as I said, they have to get rid of the percentage sign in front of it. So it's going to be this number, 0.086. And we discussed how we do that, right, before. So if you divide this number by 100, means that you have to shift the decimal point 2 on the left. So 1, 2, okay? So 1, 2 means 0.086. So when you don't have any number here, you have to put 0 there, okay? And after 1 year, it's going to be I equal to PRT. You have P, you have R, you have T. You multiply all together. Just make sure that the unit of R is the unit of T. Unit of R is per annum, per year, and this is a year. So this is everything is good. You just multiply them together, and you get the number. Okay, $275. Okay. So an interest of 275.20 was charged. Okay. All right. So another question: how much interest did Amy earn by lending $28,750 for 3 months at 6.5% per annum? Okay. So now we have the principal, we have the interest rate per annum, but they have 3 months. The period is in months. You have to convert this to a year, right? So that's the only tricky part of this question. Okay. So what's this? So again, we go solution for this. Principal is 28,750, and our rate is 6.5%, which is, as I said, we have to convert it to a percentage, and then 3 months has to be converted to a year, which is going to be 0.25 year. Okay, and then use the equation PRT, and now the P is going to be 28,750. And R is 0.065, and this guy is going to 0.25 years. So the result is going to be 467.19. Okay. All right. Let me just admit some other people to the meeting because we got some other people also joining. All right. So I'm going back to the department. All right. All right. So I'm going to give you 3 minutes to solve this, guys. Okay. Ebony borrowed $14,580 from her aunt for 2.5 years. If her aunt charged her 0.37% per annum, how much interest would Ebony have to pay her aunt at the end of the period? Okay, I'll give you 3 minutes. 3 minutes for this. Okay. All right, so the correct answer is B, as most of you guys answered correctly, and that's how we calculate it. So we want to know what's the amount of interest. We have principal amount, we have number of year, and we have interest rate, right? So it's going to be principal amount, and so okay. So the tricky part of this question is just how to convert this interest rate 0.37% to an actual number, okay? Which, as I said, is 2-digit decimal point is going to go to left. So you have to put 20 in front of 37. It's going to be 0.0037. Okay, and T 2.5 years, which is you just make it in the decimal point 2.5, and then use this equation PRT. You multiply them all together, and the result is going to be 134.87, which is a B, which is going to be the B answer. Okay. All right, another question. I'll give you guys also a few minutes for this. Martha lent $8,435 to her friend Andrew at an interest rate of 1.5% per month. Okay, it's not per annum, guys, per month. How much interest would Andrew have to pay Martha in 60 days? Okay. All right, I give you a few minutes for this as well. All right, so whoever answers C was right. The answer for C is correct. So how we calculate it? We just go to the calculation again. So we have the principal amount, P. We have R per month. We have to convert this to the actual number, which is going to be 0.0105. And then we have 60 days. So the tricky part is how do you convert the 60 day to a month? Okay, is the month 30 days? Is the month 31 days? Is the month 28 days? We don't know which month is that, right? So the best way of converting days to the months is just convert days to the year and multiply by 12. Okay, that's the best way of converting days to the months. Okay, you just divide the number of days from number of days to 365. It's going to be 1 year, and then multiply by 12. Okay. So that's the best way of converting the number of days to the months. Okay, so 60 days, you don't know what's whether 60 days is 2 months or 1 month and basically or okay, so you don't know what the 60 days, because the months can be a 31-day month, can be 30 days month, can be 28-day months, right? So the best way of converting days to the months is just divide the day by 365, because the years are always 365 except the leap years, right? 365 and then multiply by 12. So that's give you the number of months, okay? If you do that, then you're gonna end up with the final number. So how do you do these calculations? I'm sure you can do this calculation in your calculator, right? So you basically when you start from this complicated term. You first find this number and then multiply with this number, multiply with this number. Okay, so that's how you calculate it. So if you haven't got your calculator, please get your calculator as soon as possible, because we're gonna because all these courses are related to calculator. You need to use calculator for most of these courses. Okay, for all the courses actually. So you need to use basically have your calculator handy. Okay.
Excuse
right,
me, sir.
another-
Sorry to interrupt.
Yeah, go ahead.
I have a doubt. Can't we do that 2 by 12 because 60 days is 2 months. So 2 by 12.
The problem is that 60 days is not exactly 2 months, right? The months can be 31 days, the months can be 30 days, right? So you don't know whether 60 days is 2 months or close to 2 months. If you use 2 months, then your number is going to be a little bit different than the number of the answers. So that's one way of checking it. So if you put 2 months and you go with it, and then see, okay, your number is a little bit off from the answer that you have, the 4-choice answer, but it's close to 174. It's not exactly 174, maybe 175, 173, but it's close to 174. Okay, I'm going back to here. I mean this here, the answer. So the answer is 174, 71. But if you use this as a 2 months, it's going to be, your answer is going to be 175, 173. So it's not going to be exactly this number, but you take this choice anyway because these numbers are really off, the other numbers. But in some cases you don't have the multiple choice answer, so you basically need to get the final answer. And final answer is going to be wrong because 60 days, as I said, is you don't know whether it's a month or is it 2 months or more or less. A little can be less than 2 months, right? So because if you can consider a 2 months, one month is 31 days, the other month is 30 days, it's going to be 61 days. This is 60 days, okay? So that's the tricky part of this question. You need to convert these days to months. How do you do it? Divide it by 365, it's going to be a year, and multiply by 12, right? That's the best way of doing it, okay? Please do it from now on, please do that. This way of converting days to months, okay?
Okay, thank you, sir.
You're welcome. All right. All right, another question. Samantha borrowed 5,500 from her uncle for 240 days. If he charged her an interest rate of 7.28% per annum, how much interest did she have to pay him at the end of the period? Okay, I give you a few minutes for this as well. All right. We got even someone answered the whole thing in there. All right. So okay. Yeah, the correct answer is D. And how to be calculated is you have the principal, we have the rate, you have number of days. So the tricky part of this question is just you need to convert the number of days to year, right? So this is per annum, right? It's not per month, okay? Per annum, then this guy has to be, the time need to be converted to annum, to year, okay? So how do you do it? It's just divided by 365 days, okay? And now you have this number together and multiply, and you get this number, okay? 263.28. Okay, this is going to be the amount of interest that Samantha has to pay to her uncle. Okay. All right. Okay. So in some questions, you might have some question in your exam and test that you basically need to identify how many days are between two distinct points of time. So, for example, the question might ask you how much interest Samantha has to pay her uncle from March 2nd, 2005 to August 20, 2005. Okay, so something like that. So basically, that's a tricky question. You need to calculate all the number of days between two distinct points of time. Okay, so how do you calculate it? Basically, the way that you calculate it, you need to know which month is 31 day and which one is 30 days. Okay, and then you go from there. Okay, so for example, from March to August, you need to know which month is 31 day, and then calculate it to the end of the month, and then each month together, and then you ended up with the number. Okay, so the 31 days months are January, March, May, July, August, October, and December, and 30 days months are April, June, September, and November. It's very hard to remember though, right? So I just the best way of remembering is, and also February is 28 days, and on leap year is going to be 29 days. So it's very hard to remember. I can't remember it myself, but what you can do is just use your fist, basically, and basically months with 31 days are the months which you have basically the hip, or basically the hip on your fist, and the basically the anticline, the basically cline, the anticline and the cline. Okay, so is going to be your months with 31 days and 30 days. So January, February, March, April, May, June, July. Okay, it's very simple. Okay, so anytime you have difficulty to know how many days in the months, use this trick basically, and then again, August, September, October, November, and December. Okay, so it's very simple to basically remember how to know how many days in the months. Okay, so again, one more time, we can go from January, January, February, March, April, May, June, July. Okay, and then again August, September, October, November, December. Okay, and then so how do you want to determine the number of days using the calendar days in each month? Okay, while counting the number of days in a time period, we include either the first day or the last day of the investment or loan. Okay, but not both days. Okay, financial institutions generally include the first day of the period and exclude the last day. This is done because they base their financial calculation on the end of the day's closing balance. Okay, so okay, for example, calculate the number of days in the time period from November 8, 2020 to February 11, 2021. Okay, so how do we calculate this? Okay, first, we have November, we have December, we have January, and we have February. Okay, these are the months. Okay, and from November 8 to November 30 is, okay, you put 30 minus 8, it's going to be 22. Okay, but if you include the first day, it's going to be 23 days. Okay, so because if you exclude the first day, 30 minus 8 is going to be 22 days. Okay, but if you include the first day, it's going to be 23 days. Okay, 23 days this, and December is 31 day, and January is also 31 day, as the feast method, right? So you put the feast there. December, the last month, was 31 day, and January, the first month, 31 day. February is 28 days, but we don't need all the 28 because we only go to February to 11. Okay, so February until February 11, we have from February 1 to 11. So it's going to be 11 minus 10. It's going to be 10 days, and since we exclude the last days, then we stick with the 10 days. Okay, If we include the last day, we're gonna have 11 days, okay? But we exclude the last day, okay? You either include the first day, exclude the last day, or we exclude the first day, include the last day, okay? We can't have both of them at the same time. So we either have to have, as I said, we either have to have include the first day and exclude the last day, or exclude the first day, include the last day. We can't have both of them, okay, for the interest rate calculation. So basically, how we calculate it. So from November to end of November, it's going to be 30 minus 8 plus 1, because we include the first day. It's 23 days. December 31 day, January 31 day. February is going to be 11 minus 1, 10 days. And we stick with them 10 days, okay? Since we exclude the last day, okay? So it's going to be February 1st, 2, 3, 4, 5, 6, 7 to 10, okay? Not 11 itself. So the total number is going to be 95 days, and basically that's a number of days, okay? Okay, so the other method of doing this calculation is using the table. So okay, so you can have this table. I think there's some examples that they give you that table. The table is pretty handy. Basically, what you can do in the table, for example, let's say from March 4, which is going to be 63, to September 12, which is going to be 255. You just deduct to 255 minus 63 to find the difference between these two days. Okay, the table of numbers, you just subtract the basically the next date, the next date from the past date. Okay, future date from the past date in terms of the calculation. Okay, if by any chance the months, so you go from November 8, for example, like last example, you go from November 8, which is going to be 312, to February 11, which is going to be 42, right? So in this case, you have you go from a bigger number to a smaller number. Okay, there's no worries. You have to subtract the smaller number from big number, and then subtract 365 minus that number. Okay, so for example, we went from November 8, which is 312, to February 11, which is 42. 312 minus 42, it's going to be 270, I believe. And then 365 minus 270, it's going to be 95 days, which you have it in the last example. Okay, 95 days. Okay, so that's how we calculate it. So yeah, any question until now?
Excuse me, please. Could you go over that again?
You mean from November 8 to February 11?
Yeah, February 11.
Okay, so November 8 is going to be 312, right? 312, right? You see my cursor? Do you see my cursor?
Yes, I do.
Yeah, 312, November 8, okay? And February 11 is 42, okay? So you subtract 42 from 312, okay? Because you're going from November, from big number to a smaller number, okay? You have to take into account. If you go from big number to a smaller number, then you have to do this. You subtract the smaller number from big number, which is going to be 312 minus 42. It's going to be 270. And then since you move over a year, right? So you go to December, January, and February, then you have to deduct that number from 365. So 365 minus 270 is going to be your final number. It's going to be 95. Okay. You got it?
Yeah.
Yeah. So since you roll over the year, right? So you go from November to February. You roll over the whole year. If you're going from February to July, it's not going to be like that. So you subtract the big number from a smaller number, and that's over. Okay. But if you roll over from December to March, for example, or from November to April, so you roll over a year, then it's going to be that way. You have to, after subtraction, you have to subtract the whole number from 365. Okay. Any other question? All right, let's go for the next one. All right, using financial calculator. So financial calculator also make your life much easier if you want to use that, because that's much easier to use than basically the table. And how do you use financial calculator? You press second, bottom, and date, which is going to be, let me see, yeah, number 1. Okay, so second, bottom, and number 1. Okay, if you push it, you will have DT1, and you can select what's going to be DT1. 10.1817. Okay, what's this? What's this number? 10.1817 means 18 of October of 2017. Okay, so the math is like this. So as you said here, MMDDYY. Okay, that's how that's the format of entering the date. Okay, MM.DDYY. Okay, months .DD day year. So for example, if you want to put October 18, 2017, you have to put it like this. Okay, so let's do that together. I have my calculator in front of me. I turn it on. I put second and date, second and number 1, and then I have DT1. I will put 10.1817. Okay, and set enter. Okay, as soon as I put enter, automatically the date is going to be 10/18/2017, and then I use arrow down key for the date number 2. This is going to be 04.0518, and then I set enter, and it's going to be set there, and then I go down to DBD, and then I push CPT. As soon as I push CPT, I will have 169. Okay. All right. I hope you guys are having the calculator by now. Any questions?
Professor, can you help me with my calculator?
You want help with the calculator?
Yeah, I don't quite understand the terms you use.
All right. So, all right. I need to basically. Okay. So what I'm gonna do? I'm just gonna quit this PowerPoint and then show my calculator to you guys. Okay. Let me stop share. All right. So do you see this calculator right now?
Yeah, I see it.
Yeah.
Yes.
All right. So you turn it on, and you set, and you push date button here. Date button here. Okay. That's right.
Date. Where's the date?
Yeah. So the second button, you push second,
yes,
and then 1, and then number 1.
Yeah.
Okay. Second,
yes.
number 1. You see it?
Yes, sir. Yes.
Yeah. All right. So you see DT1 right now, right?
DT1.
Okay. All right. So DT1, you need to put 10.1817. I put 10.1817. Okay, like this. Okay, 10. You see this?
Yes, sir.
10.1817 DT1. Okay, and then push enter. You see enter on top, beside the CPT.
Oh, yes, sir.
Beside the CPT, see enter.
Yes, sir.
Beside the CPT, you see enter, right?
Yes, sir.
Yeah. So you set enter, and then you have DT1 now set, right? 10/18/2017, right?
Yes, sir.
Yeah.
Yep.
So now you go to DT2, which is going to be 04/05/2018. So you do the same process 04/05/2018, and then 04.05/18, and press enter. 04.05/18, and press enter. Did you do that? Yeah?
Yes, sir.
And now you have this DT2, right?
Yes, sir.
Yeah. So now you press bottom arrow, right? This arrow, the bottom arrow.
Bottom arrow.
The bottom arrow, and then
yes,
push CPT. CPT. Okay.
Yes, sir.
Yeah. And then what do you get? How much you get now? DBD.
Good. I didn't get DBD. The one.
69.
The one written in my calculator is a date.
What's that?
It's a date. 4/05/2018.
Do you have, okay, so do you have DVD or not?
No, it's written Thursday. Thursday, not DVD. THU.
I don't know. You might have different
Yes,
calculator, but do you have this, the BA2 Plus or not?
I have that BA2 Plus Texas Instruments.
Yeah, BA2 Plus, right?
Yes.
Yeah, so you should have it though, right? You go to DVD, and you push CPT. You push button CPT, and then it's gonna give you 169. Okay. Yeah. All right. Just play with it yourself. We can get too much of the
Oh,
class. Okay.
thank
All
you.
right. All right. You're welcome. All right. All right. I'm just gonna share my screen again, and we go from there. All right. All right. Do you see my screen now? Yes. No.
Yes, sir.
Do you see all right. PowerPoint.
Yes.
All right. All right, so that's how we do it in the calculator, okay? So another example, how many days between September 6 and 9, and 6 and 10? As I said, we either exclude the first day or include the first day, exclude the last day. Exclude the first day, include the last day, or the other way. Exclude the first day, include the last day, okay? Okay? Yeah, either one of them, okay? So if we include the first day, it's going to be 1, 2, 3, 4 day. And if we do the other way, it's going to be 1, 2, 3, 4 days. In both ways, you have 4 days between September 10 and September 6, okay? So another example, how many days are between April 12 and May 4th, okay? So April is 30 days months, okay? If you forget how many days in this month, you just use your fist, and you will know how many days in this month. It's going to be 30 days, and May is going to be, obviously May is going to be 31st day month. So how many days between April 12 to April 30 is going to be 30 minus 12, 18 plus the first day, okay? So it's going to be 19 days, okay? So always 30 minus 12, it's going to be 18. If you include the first day, you have to add 1 into it, okay? So it's going to be 19 days. And from May 1st to May 4th is going to be only 3 days because we exclude the May 4th, okay? So 4 minus 1 is going to be 3, okay? So that's how you calculate it. It's going to be 22 days, okay? Okay. So this is another example. You guys, I'll give you a few minutes for this as well. How many days are between December 18 and February 10? Okay, so I'll give you a few minutes for this. You can use your calculator as well. So you can put, okay, so December 18, yeah, so you can use a calculator, but you have to be a little bit smart about that because it's rollover year, right? So it's a rollover year. You can use either calculator or the table, or by hand. I prefer by hand, but I mean doing by hand. But just you can use either table or calculator or by hand. Okay. I'll give you a few minutes for this.
Hi, Professor.
Yeah.
Hello.
Yeah.
If we are calculating by hands, do we need to minus one?
I told you how to calculate by hand, right? You calculate by hand means that you put the months in front of you, and if the month is 31st day, it's going to be 31 minus the number plus 1, okay, at the first month, okay. But the last month you just do the basically, like if it's like February 10, it'd be 10 minus 1. It's just when it's going to be 9 only, okay.
Okay, because you mentioned that like back to this question, obviously it is 54 days, but you mentioned that either we include the first day or the last day.
Yes.
So I was wondering. Okay.
Yes.
Got it. Yeah.
Yes. Just either first day or the last day. Yes, that's right. Yeah. Yeah.
Okay. Thank you,
All
sir.
right. So let's go to the solution of this, because lots of people don't answer this. It's very, very simple actually. So solution is B. So how do we do it? Again, instead of December 18 to 31st, you do 31st minus 18, which is going to be 13, right? 13 plus 1, because December 18 is also included. So 13 days. Okay. So we either do first day included or first day excluded. For this example, it's a little bit confusing. I prefer to have first day included, because if we learn how to include the first day, it's just better to have the first day included. So I would say this is 14, and then we don't include the February 10. Okay, either way. Okay, so in this example, the first day is excluded. So basically 31 minus 18, and without the first day, it's going to be 13 days. January to January 31st is going to be 31 day. February 1 to 10 is going to be 10 days. Why 10 days? Why is 9 days? Because the last day is included. So as I said, it's just either you do first day included, last day excluded, or the other way, first day excluded, last day included. In this example, the author of this PowerPoint decided to exclude the first day and include the last day. But if you learn it to include the first day, please do it that way. Okay, so I would solve this problem this way. I will deduct 31 minus 18, which is going to be 13, plus 1, because you include the 18. It's going to be 14 days, 31 day, and then I subtract 10 minus 1, which is going to be 9. So it's going to be 54 again. Okay. But the other of this PowerPoint is basically decided to do the other way, which I don't like it, because you learn one way, and then this is going to be confusing, because it's going to be confusing. You learn it one way, you do it the same way. Okay, so basically do the same way. Okay, so it's going to be 14, 31, and 9. Okay. So how many days are between February 21st and June 5, 2010? Use a financial calculator, okay? So, okay, financial calculator it's going to be very simple. You turn on the calculator, you push second button and 1, and then you have DT1, right? So DT1, you put February 21st, 2010, which is going to be 02, which is a month, 21 is going to be day, and 10 is going to be year, right? 02, 21, 10, okay? And then June 5th, 2010, which is going to be month 6, 05, 2010, 06, 05, 2010, and then you press enter. Don't forget, you have to press enter as soon as you put that number in front of DT1, okay? You press enter, and then you go to DVD with the arrow key and push CPT. It's going to be 104 days, okay? All right, so this is basically the first part of the lecture. We need to move to the second part before we're running out of time. We need to get a break at 11:10, I would say. So let's see if we can make it, okay? Any question on this before I move to the other one? Any question? No question. All right, so I'm gonna stop sharing this, and I close this.
Hello.
I hope I can. Yeah, hello. Yeah, yes.
Yeah, so I
Yes.
have a question. Actually, I can't understand the like how to calculate the day. So can you please repeat it?
By hand or by calculator?
By hands.
By hand. All right. All right. Okay. Okay. All right. Let me just open the PowerPoint again, and then go to Window, Share. Do you see this now? You see this PowerPoint?
No.
You don't see? Oh my God, the same glitch as the Zoom glitch. Okay. All right. Let me stop sharing. I need to share my whole screen then. Entire screen. You see my my screen now?
No,
Yeah. My screen. Just you see the PowerPoint now?
no,
No,
no.
sir.
You don't see my screen?
No, Professor.
That's all right. So let's. What about now? Okay, now you can see my screen, right? So yeah, you see the PowerPoint now?
Yes.
Yes.
All right. Okay. All right. So how do we calculate the date between? Let's see. Let's go to a simple one. Okay. All right. Yeah. Let's go to this one. Okay. So how many days are between November 8th and February 11th? Okay, let's do this one. Okay, the other one is a little bit confusing. I just don't want to make you confused. Okay. So November is 30 days months. Okay, the November has 30 days in it. So you put like this from November 8th to November 30. Okay, you put like this from November 8th. So you want to calculate the whole days from November 8th to February 11th. So you want to calculate all the days which you have in November, all the days you have in December, all the days you have in January, and all the days you have in February. So until February 11th. Okay. So how do you do it? So from November 8th to November 30, you have 30 minus 8, which is 22 days. Okay. But you have to include the first day, which is November 8th. So it's going to be 23 days, okay? So 30 minus 8 plus 1, always like that. 30 minus 8 plus 1, okay? 23. December is 31st days. January 31st days, 31 day, and then February is always like this. Always 11 minus 1. It's going to be 10, okay? So 23 plus 31 plus 31 plus 10. Okay, it's got 95 days. Okay, you understand it now?
Yes, understood.
All right, sounds good. Sounds good. All right. Okay, I'm just gonna close this and then open the other one. We're running out of time, so we're probably gonna be running out of time for. We have 4 PowerPoint for this course, but probably gonna be running out of time. So it's gonna be the last PowerPoint. Probably gonna be. It's not going to be finished. Probably not going to be finished. And then we have to next week we're going to start from the point which we depart from the first PowerPoint. Okay, so now we're moving to other subject, which is calculating principal, interest rate, time, and maturity value. Okay, so we learn how to calculate the interest, right? So interest is going to be principal multiplied by rate multiplied by time, okay? And we have to make sure that rate and time are the same unit, okay? And to solve for principal, okay, so if you want to solve, so now we solve for interest, right? Interest is going to be principal time rate and time. Okay, sometimes they are tricky questions. Sometimes they give you only interest rate, interest, and the times, and they ask for what's the principal, okay? To solve for principal, you need to basically use the same equation, but just the other way. So the principal is going to be interest divided by RT, or you can solve for interest rate, which is going to be R, is going to be I divided by PT, or you can solve for time. It's time equal I divided by PR. So basically, you can solve any of these variables within the equation by using the other 3. Okay. Or if you can put it in triangle mode. If you put it in triangle mode, so you can put just a triangle, I on top and P and R and T on bottom. So if you wanna solve for P is gonna be I divided by RT. If you wanna solve for R is gonna be I divided by PT. If you wanna solve T is gonna be I divided by PR. If you wanna solve for I is PRT. Okay, so that's triangle mode. So if you're more comfortable to put in to just picture this triangle and basically solve the problem. Basically, we'll look at the triangle. Okay. All right. So let's solve an example for this. Henry had to pay $350 as interest payment on a loan. So now we have the interest. Okay. So $350 interest payment on a loan that he had taken for a period of 5 months. If he received the loan at 9.28% per annum, what was the principal amount of the loan? Okay, so right now we have interest. We have to identify for this equation. We have interest, we have time, we have R. We have R, we have T, and we have I, but we don't have P. So what's a P? Okay, so I equal PRT, so P equal to basically I divided by RT, right? So so the equation is basically what's the P? P I divided by RT, okay? So because I equal PRT, right? So P is going to be I divided by RT, okay? So now we have I, we have basically interest rate, which is going to be 0.0928, and we have time, which is 5 months, okay? As I said, the 5 months need to be converted to year, right? So because the interest rate is per annum, okay? So interest rate is per annum. Time has to be divided. Time has to be a year. So now we have I, we have R, we have T. They are all the same unit. Then we can use the calculation, which is P I divided by RT. Okay, based on the triangle. If you remember the triangle, P is going to be I divided by RT. Okay, always remember triangle. Okay. I divided by RT, then we put the equation there, and then we're going to solve for it. Okay. All right, so let's do another example. A short-term loan of $18,000 is issued to an employee at 7.8%. Okay, so now we have the principal because the principal is short-term loan. Okay, $18,000, and we have the interest rate as well. So per annum, what was the time period of the loan rounded up to the next day if the interest charge was $2,400? So now we have also interest. We have interest. We have we have interest rate, we have P, we have R, we have I, right? So what we need to know, we need to know what's the T, okay? So P equal to I equal to PRT, right? So I equal to PRT. So T is going to be I divided by PR, right? So that's based on the triangle. So let's solve it then. We have principal, we have R, which is going to be interest rate, and we have I, which is going to be interest itself. So we don't know what's the T. Okay, so T is equal to I divided by PR. Make sure that everything is in the same unit. The T and R has to be in the same unit. Okay, so if you put the interest rate as per annum here, so the result is going to be per annum. So we want to know. You want to know in day, right? So we want to know what's the period in day. But what it's going to give you is going to be 1.7. If 1.7 is not day, is per annum because you use per annum interest rate. Okay, so it's going to be based on year, and then you have to calculate it based on the number of days, which is going to be 623.93 days. Okay, and if you round up to the next day, it's going to be 624 days. Okay. Any question until now?
Excuse me, sir. It is necessary to calculate in days.
Can you repeat your question?
As we multiply it by 365, so is it mandatory to calculate in days, or we can just say 1.70 years?
No, it said rounded up to the next day, right? What was the time period of the loan rounded up to the next day. If it doesn't have the rounded up to next day, you can put it as years, 1.7 year, okay? 1.71 year, okay? Because you have to round it up to 2 digits, so 1.71 year. But if you say rounded up to the next day, immediately you need to calculate based on days, okay?
Okay, thank you.
You see this? Yeah. You see this rounded up to the next day? You see my cursor? You see my cursor? Yeah?
Yeah.
All right, okay, all right. All right, what was the rate of simple interest per annum offered on a saving of $6,500 if the interest earned was $300 over a period of 6 months, okay? Now, in this case, we don't know what's the rate, okay? So always I equal to PRT, and now R is unknown, okay? So we have I, which is interest. We have P, which is basically this guy, 6,500, and we have T, which is time, okay? So now we need to know what's R. So R is equal to I divided by PT, right? Based on the triangle, guys, okay? So so we have P, we have I, we have T, okay? So we want to know what's R, okay? So you just put this guys in there. It's gonna 300 divided by 600, 600 by 6. It's gonna be this, but this is monthly, right? Because we put T as a month. If you put T as a year, which I prefer to do that, they just convert this to a year, and then we get the rate as a per year or per annum. But since we put it as a month, then this is gonna be a monthly rate, okay? So, and then we need to convert this to a year by multiplying by 12. So it's gonna be 9.23% per annum, okay? So it's always important, what's per annum, because the question is simple interest rate per annum. When they say per annum, I would just convert the T 6 months to the year. It's going to be half a year. So put 0.5 here, and they do the calculation and come up with this guy, okay? Or the other rate that he's doing here is converting this month, is using the months, and whatever you find is rate per month, okay? And then you have to convert to annum, okay? Whatever you put time unit, the rate is going to be in the same unit, okay? So it's very important that you remember any unit of time you put there, the calculating rate is going to be the same unit, okay? A rate unit and time unit has to be the same, okay? All right, okay. All right, so calculating maturity value. So what's a maturity value? Maturity value is this principal value plus amount of interest, right? So just your total money after you put your money in the bank for a year or 2 years, the maturity value is the final money, all the money you have, principal plus amount of interest. So that's going to be a maturity value, okay? Or final value, or accumulated value, or future value. They are all the same meaning, okay? Accumulated value, future value, maturity value, they're all the same meaning. So they are basically all the same concept. So it's going to be principal plus interest, okay? So that's your final basically value of the money you get basically after investing your money, okay? We also can calculate interest based on the maturity value and principal. It's going to be maturity value minus principal. It's going to be interest. Or we can also do principal. It's going to be maturity value minus interest. Okay, so these are, if you know the first equation, the first formula, the rest is going to be easy. It's the same as P equal to I equal to PRT. Okay. Okay. If we substitute the I as PRT here, then we're going to have this equation as maturity value. So maturity value is going to be P1 plus RT, okay? P1 plus RT. So maturity value is principal 1 plus RT, okay? Which is the same as P plus PRT, which is going to be P plus I, okay? But some question they ask you, what's the principal? So they give you the maturity value, and they say what's the principal? Okay, they give you maturity value and RT. They ask you for principal. So for that, you need to basically isolate for P. P is going to be S divided by 1 plus RT. Okay. what I recommend, you guys just learn the S equal to P 1 plus RT. Okay, you just remember this equation, and then the rest is gonna come handy. The rest is gonna you can use this equation to find the rest. Okay, so I don't recommend to remember a lot of equations. Okay, or a lot of formulas. Just one formula, and the rest you can drive this guy from this guy, right? So you don't really remember to learn a lot of equations. Okay, the same for the same for P equal to I equal to PRT. I would just remember P. Sorry, I would just remember I equal PRT. Okay, and then the rest, like how do you find P? P is equal to I divided by RT, right? So or the other one. So it's just one equation. You remember one equation. The rest of the equations are the rest of the formulas. It's just algebra, simple linear algebra, right? So just remember one equation, S equal to P 1 plus RT, and the rest is going to be easy to remember, easy to drive, I would say, not to remember, easy to drive. Okay. Yeah. So the other way is going to be S divided by 1 plus RT, which is 1 plus RT minus 1. Okay. All right. Let's solve a question, guys. Let's do this for. I'll give you a few minutes for this as well. Lucy accumulated $6,500 in a mutual fund after investing for 2 years. Okay, if the simple interest rate is 6.5%, how much did she invest at the beginning? Okay, I'll give you a few minutes for this. This is basically what we have here. You have a maturity value, accumulated value, and we have time, and we have rate. We want to know just the principal. What's the principal? Okay, I'll give you a few minutes for this. Okay. Oh, we got a lot of smart guys there, huh? All right, most of you guys answered correctly. We're gonna solve it. Okay, so yeah, D is right. Yeah, congratulations to those guys who are answering right. You see, a lot of you guys are answering it right. So it means that you understand the concept of this and you apply it. You apply it correctly. Congratulations to you guys, because this stuff you learn it that fast and you apply it so fast is pretty good. Yeah, I admire you guys. Okay. All right. So how do we solve it? So we have basically we have the maturity value, the S. We have it. We have the rate, which is 6.5%, which is going to be 0.065. And we have the year, the T, which is total number of year. We have the equation S equal to P multiplied 1 plus RT, right? So or the other way, P equal to S divided by 1 point RT, or S multiplied by 1 plus RT minus 1. And then we put the stuff there, and we calculate. You know how to use the calculator, right? So it's going to 1.13 power minus 1. You have one. In calculator you have 1 over x, 1 over x2, right? So you can use that, and then use that. Okay. So I I hope you guys are familiar with the calculator, how to calculate this guy with the calculator. So if you have questions, let me know. Okay. Any question until now? Okay. All right. So Sean received an amount of 1690 from a pawnbroker at an interest rate of 4.75%. Okay. He received this amount at the beginning. Okay. So it's principal amount, and interest rate is per month, guys. 4.75% per month. Okay. Calculate the maturity value of this loan and amount of interest he would have to pay to repay at the end of 3 months. Okay. So this is per month. Don't forget, this is per month. Okay. So per month you have to pay this. So after 3 months, calculate the maturity value and interest. Okay. Very simple. You have principal, you have interest rate, and you have time. Okay. So use that equation, P1 plus RT, or what other way you can do it, P plus interest, and interest is going to be PRT anyway. So the other way is fine, and you put the stuff there and you solve for it. Okay, simple. This is maturity value, and you want to know what's the interest. You subtract the maturity value from principal. Sorry, you subtract principal from maturity value. So it's going to be 930 minus this, it's going to be 240. Okay, it's a very simple question. Okay. All right. Another question. I give you a few minutes for this as well. Javier has an amount of 6,870.75 in an investment at the end of 8 months. Okay. So he has this amount at the end of 8 months. Okay. Not at the beginning of the 8 months, at the end of the 8 months. And it means that this is a maturity value. Okay. At the end of 8 months. If the investment was growing at 5.69% per annum, calculate by the amount invested was the principal and the amount of interest earned, and I. Okay, I'll give you a few minutes for this as well. I'm gonna do it myself in the calculator as well. All right. Congratulations to you guys. Wow. Oh, a lot of good answers, huh? A lot of correct answer. Yes, answer is A. How we do it? Basically, S is amount of maturity value, right? And you have the time. We have R. Time. You have to make sure that. Okay, so we have R in per annum, right? So it's going to be per year. So you need to convert the months to a year. Okay. So that's how we convert the months to the year. Okay. 8 divided by 12 is going to be 0.66, and then use that equation. Okay. As I said, you just remember the first equation. SP one multiplied. Okay, so S is going to be P multiplied by 1 plus RT. Okay, you remember that guy. The rest of the equation can come in your mind. You can do it back of your head. So P is going to be S divided by 1 plus RT. Okay, just the first equation. Remember the first equation. This equation comes after you remember the first equation. So you right now you need to know P. P is going to be S divided by 1 plus RT. Okay. You don't need to remember all the equation. Just the first most important equation. Remember, the rest is going to come from linear algebra. Okay. And then you put the stuff there, and you do the simple calculation and this. Okay, so it's going to 66, 19.85, and how much interest he earned? You deduct this number, which is going to be principal value, from the maturity value, which is going to be S minus P, this guy minus this guy, 251. Okay. All right, guys. So we're done with the first part of the lecture. We will. Okay. So any question until now? Any question? I'm just going to stop sharing this. Any question before I stop sharing this?
Okay.
All right. So yeah, that's good. That yeah, Leila is right. Yes. So 6. Yeah. Okay. So yeah. So if you don't have any question, we're gonna reconvene at 11:25 after 15 minutes break, and then we go for the next part of the lecture. Okay, guys. All right. See you at 11:25. Okay. All right. Bye for now. All right, guys, we will start in a minute. Any questions so far? All right, I don't see any questions. So we're going to start the next part of the lecture. It's going to be the compound interest rate. So I'm just going to share the PowerPoint, see whether you can see it. If you don't see it, then I need to share the whole screen. So I hope you can see the PowerPoint. Do you see the PowerPoint?
Yes, sir.
All right, sounds good. All right, so in this part of the lecture, we're going to discuss compound interest rate, okay? So far we learned the simple interest rate, which basically simple interest rate is just come with basically is no matter how many years it is or how many times you just multiply the for interest rate, you multiply principal value by interest rate by the time, okay? And doesn't matter, time is not really is not compounded. So in compound interest rate, the time is compounded, and I'm going to discuss what is compound means, okay? So so for simple interest rate, if you remember, after 3 years of investing, you have $100, which is the investment just interest rate is just calculated based on the principal, the amount of principal, and basically after 2 years you will have $100, which is going to be $1,300, right? So this the simple interest rate. The equation is very simple. You have principal, you have interest rate, and you have time. You multiply all together, you will find the interest, okay? That's for simple interest rate, okay? So the principal always stay the same in simple interest rate. In simple interest rate, principal always stay the same. But for compound interest rate, basically compound interest rate is how the bank work, right? And how the banks work are basically is compounding the interest rate. And how does it work? Basically, you have the principal amount. After 1 year, you have you earn interest of $100 on top of this guy, which is going to be $1,100. Okay, so principal was $1,000. After 1 year, it's going to be $1,100. Okay, so and that this is going to be new principal for next year. So for next year, you're going to have 10% of this guy rather than 10% of the original principal. You have new principal right now. So for the new principal, it's like you invest and reinvest in the bank, right? So you take, it's like you take your money out after a year and then put it again as a new principal. Okay, that's how the concept works. So the concept of compound interest is like you put your money out, get your money out, the whole money out, like the accumulated maturity value out of the bank, and then again put it as a new investment. So you have new principal now. So an interest on this guy, for 10% of this guy is going to be $110, which you added on top of this is going to be new principal for the third year. This is going to be new principal for the third year. For the third year, you will have again 10% of this guy. It's $121. And then you add on this guy, and then it's going to be the whole. It's going to be the whole amount of the money, the maturity money, or the final value of the future value of your money is going to be the original plus interest for first year, interest for second year, interest for third year. So interest for this case $331 rather than $300. So for compound interest with the same rate, 10%, with compound interest you will have more money than simple interest, okay? Because you basically take your money out at the end of the compounding period and put it again as a new investment, as new principal value, okay? So that's the whole concept of compound interest works, okay? Any question until now? Okay, so look like everyone understand this. So interest amount stays the same for every period in simple interest rate. Okay, for every period of a year, the interest is going to be the same, and is calculated based on the principal. But for the case of compounding, as I said, interest grows with every period in compound interest. Okay, so interest grows. Interest first year is the same as it's simple. Second year is 110. Third year 121. Fourth year is going to be more. Third year is going to be more. So it's going to, the interest grows exponentially, basically, in compound interest rate. Okay. And if you want to show it in terms of graph, as I said, the simple interest is going to be linear. So RT, right? P interest equal to PRT. See, basically linear in time. In time, when time grows, the interest is linearly grows. But in compound interest, when the time grows, the interest grows exponentially. Okay. So that's the difference between the compound interest and the basically simple interest. So, all right. Example: $1,000 was invested as an interest rate of 10% compounded annually for 4 years. What was the value of this amount at the end of 4 years? Okay, we already discussed that. So $1,000 after 1 year is going to be $1,100. After 2 years, is going to be, you have to calculate the rates on that. Okay, so you do it like that. So the $1,000 after first year, it's going to be 10% interest. It's going to be $1,100 here, and then again 10% of this guy is going to be $110. On top of this is going to be $1,210. 10% of this guy is going to be $121, and added to this guy is going to be $1,331, and 10% of this guy is going to be $133.1. Added to this guy is going to be 1464.10. Okay, so that's the value of the money you get after 4 years. But if it was a simple interest rate, just 4 by 10% is going to be $400, and with 1,000 is going to be 1,400. So you save $64 more when you do it compounding. Okay. So which statement best describes simple interest? Okay, A, the growth of an investment over the time period is exponential. Not true, because we are talking about simple interest. B, the interest amount earned is reinvested at the end of every period to earn interest on the new principal. This is not true. This is simple interest. It's not true. It's for compound. This is for compound. C, the interest amount grows for every compounding period is not true, because we are talking about simple interest. So this is not true as well. D, the interest amount is calculated on the original principal for the entire time period. That's right. So that's D. Okay. So the whole interest amount is calculated based on the original principal, not based on the accumulated principal. Okay. So it's just the simple interest is like that. Which is the best described compounding interest? A, the interest amount is calculated on the original principal for the entire time period. No, that's not right. This is simple interest. B, the growth of an investment over the time period is linear. This is not true. This is for simple interest. C, the entire amount earned is reinvested at the end of every period to earn interest on this new principal. That's right. This is the right one. So C, the interest amount is reinvested at the end of every period to earn interest at the new principal. That's right. This is true. And D, the interest amount is the same for every compounding period. It's not true. So C is true. Okay. All right. So how do we calculate the future value for an extended period of time? Okay. So now that we learned what's the compounding basically interest rate look like, so we need to know two important concepts. One is compounding period, and the other one is basically the I, which is going to be interest periodic interest. So there are two important concepts you need to learn about the compound interest rate. One is the I, which is going to be periodic interest or compounding interest, and second one is the compounding period. Okay, so you have the compound. So, for example, the compounding period can be year, it can be months, it can be days, it can be semi-annually, it can be quarterly. So compounding period can be different than annual period. Okay, so so it means that if the compounding period is like half a year, so it will be okay. So if the compounding period is half a year, it means that you take your money out every half a year and you reinvest it again. Okay, so the compounding period in that case is going to be half a year. Okay, if the compounding period is monthly, it means that every month you take your money out and you reinvest it again. Okay, so that's how the compounding work. Okay, so the compounding period can be a year, can be 6 months, can be 3 months, can be 1 month, can be day, even day, so daily. So for example, some banks right now, if you go to talk to RBC, I believe, or TD, I don't know which one is that, they do compounding daily. So basically, if you put your money there and you want to get the interest on it, so you can get basically daily compounding. So every day is going to grow. So your investment is going to grow. Okay, so so that's how it works. So basically, you have the principal value and you calculate the number of compounding periods. So you have first compounding period, your principal value is going to be 1 plus I. This is a basically periodic interest. So the interest which you earn in that period, they call it periodic interest. Okay, so the interest which you learn on that period is a periodic interest. You 1 plus I multiplied by principal value is going to be your the first compounding period value, and the second one again you multiply 1 plus I, and third one 1 plus I, and after nth compounding period your value is going to be principal value 1 plus I power n, which is going to be number, n is going to number of compounding period, I is interest, periodic interest rate, basically interest rate which you earn in that period. Okay, interest rate you pay you earn in that period. Okay, this is important formula you have to remember. So future value FV is equal to PV, principal value 1 plus I power n. I is periodic interest rate and n is number of compounding period. Okay, so so if you remember the first equation, then you basically sometimes the question they give you the future value and the periodic and the compounding period. They ask you for principal value, so you can extract principal value easily from the first equation. Okay, or the other way, it's going to be f divided by 1 plus I power n, or 1 plus I power minus n. Okay. All right. So and the interest that you earn after the whole time after n compounding period is going to be future value minus principal value, obviously. Okay, so now two important concepts. We need to discuss two important concepts before we move to examples. Okay, one important concept is compounding frequency. Okay, so what is compounding frequency? The compounding frequency is the number of periodic interval you have in 1 year. Okay, for example, if your compounding period is 1 year, the compounding frequency is going to be 1. Okay, if your compounding period is every 6 months or semi-annually, the compounding frequency is going to be 2. Okay, if the basically compounding period is quarterly or 3 months, the compounding frequency is going to be 4. If it's monthly, it's 12, and if it's every day, it's going to be 365. So you have to remember this compounding frequency is the number of the time period that if you accumulate them together, it's going to be 1 year. Okay. So how many months in a year? It's 12. How many days in a year? It's 365. How many 3 months in a year? Is 4. How many 6 months in a year? Is 2. And how many years in a year? Is 1. Okay, so that's compounding frequency. You have to remember that you have to, and it's called M, and it's basically calculated based on the based on how many of that period of time accumulated together is going to be 1 year. Okay, and so compounding period is the period of time between the compounding of interest. Okay, the length of compounding period is the time interval between successive interest calculation dates. Okay, compounding frequency M is the number of time interest is compounded every year. Okay, so what does it mean? It means that you, for example, if you have compounding period of 1 month, you take your money out of the bank and you basically put in the bank every month. And how many times you do it in a year? 12 times. So the compounding frequency is going to be 12. Okay, so that's what's compounding frequency. That's how compounding frequency is calculated. Okay, for example, here if you have compounding period of 1 year, then the compounding frequency is going to be 1. If you have compounding period of 6 months, then it's going to be 2. The compounding frequency is going to be 2, or semi-annually, it's going to be 2. If it's 3 months or quarterly, the compounding frequency is going to be 4. And if it's 12 months, if it's just 1 month, compounding period is 1 month, then the compounding frequency is going to be 12. And finally, if the compounding period is just 1 day, then the compounding frequency is going to be 365. Okay, example. So for this example, we just want to know what's the compounding frequency. 4%. So in the example, in the question, they ask you, so the interest rate accumulated at 4% compounded annually. When they say compounded annually, means that means M equal to 1. Okay, if they said 5%, for example, 5% compounded semi-annually, then the M is going to be 2. And again, if it's say quarterly, M is going to be 4. And if say monthly, M is going to be 12. And if daily, M is going to be 365. So for all the example, you see that percentage they say, this percentage is per annum. Okay, so this is the nominal interest rate. We're going to discuss this later. Okay, so this is nominal. Always in the example, if they said X% compounded quarterly or annually, that X% is always per annum. Okay, and you have to and then you have to convert it to periodic interest rate, which we're going to discuss it in a few next slides. Okay, but always this is per annum. Okay, always this percentage which I gave you, they're always per annum, unless they specify, say, per month. Okay, but always is per annum. Okay, so nominal interest rate basically, as I said, is just this percentage which comes basically before the in the example, it just comes in the example. This is called nominal interest rate. Okay, these are per annum, always per annum. Okay, is provided with the compounding frequency M and can be easily remembered as J compounded M. Okay, is always in the example. In the next example, we will see it says 6% compound monthly. Okay, when they say 6% compound monthly, it doesn't mean 6% monthly. It means 6% per annum, and then you have to basically calculate what's going to be monthly periodic rate, which we're going to discuss it later. Okay, so now there are two other concepts: the nominal interest rate, which is always going to be per annum, and also periodic interest rate. So what's periodic interest rate is very important. Is nominal interest rate divided by compounded frequency. So as I said, so for example, if you have like 12%. If you have 12% nominal interest rate, so per month is going to be 1%. Okay, so that's how we calculate periodic interest rate. Periodic interest rate is going to be nominal interest rate. It's going to be per annum divided by compounding frequency. Okay, for example, if it's 12, if basically if your compounding frequency is 12. Then the J has to be divided by 12. So then the nominal, which is annual, has to be divided by 12. Okay, that gives you periodic interest rate. Okay, all right. For example, if 6% compound monthly means that you have to divide by the 6%, 0.06 divided by 12, it's going to be 0.005 per month. This is going to be periodic interest rate. So the periodic interest rate is calculated based on the nominal interest rate based with this equation: J nominal interest rate divided by compounding frequency. Okay. All right. So, okay. So, any questions so far?
Excuse me, Professor.
Yeah.
Can you please explain nominal interest rate again?
Yeah. Nominal interest rate is just the interest rate per annum. Okay. Per year. Interest rate per year, they call it nominal interest rate. Okay. So, and like in this example, when they say 6% compounded monthly, the 6% is going to be nominal interest rate. Okay, that's called nominal interest rate. The interest rate which that give you in the examples. Okay, is called nominal interest rate. Okay, and then if you but we are interested, because I'm just going to go back to the slides that we explained the equation. Okay, yeah, this equation. Sorry. Yeah. Sorry, this equation. Okay, this equation. Okay, so the whole thing, the whole thing which we are doing in this lecture, we just want to use this equation. Future value is principal value 1 plus I power of n. Okay, I is in this case is periodic interest rate, and n is basically the whole number of compounding period. Okay, so first for any example which we're going to see in future, we wanna construct I and construct n. These two are very important. We want to construct them in order to use this equation. Okay, for this guy's construction, we will explain. We will basically have some slides to how to construct. So for I, for now we know how to calculate I. I is going to be J, the nominal interest rate, divided by M, compounding frequency. Okay, and now we're going to discuss about N, but how to calculate N. Okay. I'm going to go back to that same slide. So J divided by M, as I said. And how do we calculate N compounding frequency from time period T? So from time period T that they give you, for example, in the example, they say like 3 years or 4 years or 2.5 months or whatever. They give you time period. They don't tell you what's the compounding period, right? So then you have to find the whole compounding period, N, okay? So how do you calculate N based on the compounding the time period? N is going to be compounding frequency multiplied by T in a year. So T has to be in a year unit, and you calculate N, the number of compounding period, based on compounding frequency multiplied by T, which is going to be time in a year. Okay. So now we learn how to calculate N, how to calculate I. Now we can use the equation of future value equal to present value 1 plus I power of n. Okay. For example, if in the example they say 6% compounded semi-annually for 5 years, then what's going to be I? I is going to be this guy divided by 2 because it's semi-annually, right? And M is 2, so I is going to be 3%. And what's going to be N? N is going to be 2 multiplied by 5. It's going to be 10. Okay. So M is going to be 10. Okay. You understand it? So N is M, compounding frequency, multiplied by time in a year. Okay. Yeah. All right. So let's do some example. If you do example, we're gonna learn it faster. Okay. So for example, when they say 6% compounded semi-annually for 4 years, number of compounding period. What's going to be this one? 2, right? Semi-annually, compounding frequency. We want to know what's compounding frequency. M, 2. Nominal interest rate is 6%, right? Term in years, 4 year. And number of compounding periods for the term, number of compounding period. And M multiplied by T, 2 multiplied by T. It's going to be 8, okay? So 4.32% compounded quarterly for 9 months. So compounded quarterly means every 3 months. So it means M is going to be 4, right? So 4 3 months is going to be 1 year. Nominal interest rate J is going to be the same, 4.32. Term in years, 9 months. Have to convert to years, 9 over 12. And number of compounding period for this is going to be M, which is M, multiplied by T, okay, which is this guy. So 3. 4 multiplied by 9 is 36 divided by 12 is going to be 3, okay. 0.6% compounded monthly for 1 year and 6 months. Okay, so monthly. So monthly means compounding frequency is going to be 12. What's going to be nominal interest rate? It's going to be 0.6%. What's going to be term in year? 1 year and 6 months. Okay, terms in year. T is 1.5, 1.5. The number of compounding frequency is going to be 12 multiplied by this guy, 18. Okay, that's how we calculate the basically n here. Okay. All right. So I'll give you a few minutes for this. With 12% compounding quarterly for 4 years, what is periodic interest rate and then a number of compounding period? Okay, I'll give you a few minutes for this. All right, the answer all right. D. So 12% compound quarterly means that basically 12% divided by 4, which is basically compounding frequency, is going to be 3%. And number of compounding periods is going to be m multiplied by number of years, which is going to be 4 by 4, 16. Okay. Okay. In an investment that is earning 2.25% compounded monthly for 2 years and 3 months, what is the periodic interest rate and number of compounding period? Okay, I'll give you a few minutes for this as well. You got the not the same opinion. Not the same opinion here. Okay. I'll give you another minute. A minute. All right, so the correct answer is going to be C. Why is C? Why is not A? Because you have a rounding effect, right? So you have to round the. Okay, so let's do this. Okay, so what you guys see? So interest rate is going to J divided by M. J divided by M is going to 0.001875. Okay, and you have to round. You have to round that. So because if you put 0.19, you 0.18. That's right, 0.18. But the problem is that 7, you have to round it rounded toward the 8. So it's going to be 119. Okay. That's a rounding thing. Okay. That's the confusion about this question is a rounding thing. 0.18 is in there as well, but the 0.10 is not the right answer because you have to round the 7 toward the 8. So it's going to be 0.19. Okay. Just make sure you have this. So to 2-digit is 2-digit rounding. Okay. So you have to put the, if the number after 8 is 5 and higher, this is going to be 9. Okay. If the number after 8 is going to be 0 to 4, this is going to stay 8. Okay. So this is important. These two numbers, the number after 8, the right number after 8 is very important to do the rounding. Okay. That's a little bit tricky part of this question. Okay. That's okay. You guys can't calculate it right, but the tricky part is just that. And n number of compounding period is going to be time, the year, 2 and 3 months, 2.25 multiplied by compounding frequency, which is going to be 12. 12 or 2.25, 27. Okay. So answer is C. Okay. It's fine. All right.
Why,
so, yeah.
why did we divide it by 12?
Why did we divide by 12? Oh my God. All right. So, okay, the reason that we divide, this is nominal interest rate, right? So from nominal interest rate, you need to find the periodic interest rate, right? The question is periodic interest rate. Periodic interest rate, based on the equation, is nominal interest rate divided by compounding frequency, okay? What's the compounding frequency? It's a 2.25% compounded monthly. So the frequency is going to be 12, right? 12 months in a year. 12 months in a year. So 12 is going to compounding frequency. And J is a nominal interest rate. So nominal interest rate, which is 0.025, because we convert this guy from percent to number, okay? So it's going to 0.0225 divided by 12. You put in calculator, it's going to be this guy. And if you round it, if you basically convert it to percentage, it's going to be 0.1875. And then if you want to keep only 2-digit, you round this guy to the nearest number, which is going to be 0.19. Okay, you understand this?
Yes, sir.
Yeah. So it's nominal divided by compounding frequency. Nominal interest rate, compounding frequency. That's going to be periodic interest rate. Okay. Yeah. Any more questions on this, guys, before we move to the next PowerPoint? All right, no more question. We're going to move to the next PowerPoint. It's going to be the last PowerPoint. This PowerPoint is going to be a big one, and then we need to basically. Oh my God, did I? All right. Okay. Anyway, this one is going to be more complicated and a big one. So probably we don't have time to finish this, but we try. We try our best. Okay. Do you see this? Do you see this?
No.
No?
No.
Again, no?
No.
Oh. All right. So let me just share my whole screen then. Okay. Do you see this?
No, sir.
Not yet.
Oh my God, this Zoom is giving me trouble.
No,
Not yet?
not yet.
No.
Oh my God. I don't know what's wrong with this Zoom. You see this
No.
now?
No.
No.
Oh yeah, okay. Oh, you can see my screen now, right?
Cannot. Yes.
Yes.
Yes, we can now.
All right. You can now?
Yes, we can. We do.
All right, sounds good. All right. All right, so let's go to solve more example on compounding interest. Okay, so now this PowerPoint is all about examples of calculating the future value for with compounding interest. Okay, so until now we learned how to calculate basically I, which is nominal interest rate, and N, which is going to be compounding period, right? So number of compounding period. So we learn how to calculate this, learn how to calculate this guy, and now we basically need to solve some question, some example for this guy. Okay. First of all, how do you do it in calculator? Okay. So how do you do it in calculator? So if you open your calculator, there is a white row of N, 1 I over Y, PV, PMT, and FV in the calculator. Is a row of the number. Okay, so this is so important that the calculator is even have basically a row of bottom basically specified to it. So now how to basically do an example in calculator. We'll come back to it, but just be familiar. The N is a number of compounding period. I over Y is nominal interest rate. And P over Y and C over Y are M, the compounding frequencies. These are the same. P over Y and C over Y, they are the same compounding frequencies. They are the same. PV in principal value. PMT is annuity. For now, we haven't get to annuity yet, so that's you put it as just 0. You don't care about it. And FV is the future value. So basically, in the calculator, you can set all those numbers, and then you go to FV and press CPT. It's going to calculate you the amount of FV, future value. Okay, so that's how you set it up in calculator. We come to some example for this in future as well, but just make yourself familiar with this guys. Okay, we come to example for this later. Okay. Okay, so in calculator, if you want to set it right, so if you basically put an investment, okay, so what's the difference between the outflow and inflow? Basically, negative sign and positive sign of the present value. Okay, the present value can be negative signs or outflow if you invest. So if you take out the money from your bank and take your money from your bank account, from your business bank account, and put it in the bank as an investment, or put it in the house as an investment, whatever investment you do, it's called outflow, and sign is going to be negative in the calculator. Okay, and anytime is going to be loan, which you receive the money from bank, is going to be inflow, which is a positive sign. Okay, and obviously when you invest the money, then in the future you will have more money than whatever you invested. So in future value, when you withdraw that money, it's going to be inflow to your bank. Okay, because you basically take the money at the beginning, and then now you take the money out, and then it's going to be inflow in your bank. And opposite for the loan, right? So when you take the loan, and then you have to pay back the future value with interest, so it's going to be outflow. Okay, so that's a sign convention you need to remember for basically future value calculation. Okay, so this is what I said already. And now if you are asked to find the accumulated value of an investment, you need to calculate the interest accumulated over the period, present value of the investment, future value of the investment, present value or future value depending on the data provided. So let's go to a question again. If you are asked to find the accumulated value of an investment, you need to calculate the interest accumulated over the time. No, you want to calculate the accumulated value, right? So you want to know interest plus principal. So it's not right. Present value of the investment is not right, because you want to find the accumulated value. So see the future value of the investment. Yes, that's right. This is the one. This is basically you want to know what's the future value of investment. So that's going to be the accumulated value, right? and D, present value or future value depending on the data provided. So no, it's just a C is right, okay? All right, so ABC Mobile invested $500 for 3 years at 4.8% compound annually, okay? What was the accumulated value of their investment at the end of 3 years, okay? So now, now we go through the equation. So we have the principal value, we have a time period, and we have basically 4.8% compound annually. Compound annually means M equal to 1, right? So so let's do this. I equal J divided by M. J is 4.8% divided by 1. It's going to be 0.048. And then N is going to be basically compounding number of compounding period is going to be M multiplied by 3, right? M multiplied by time. M multiplied by 3 is going to be 3. So now future value is going to be present value, which is going to be 500, 1 plus I power of N, 1 plus I power of N. And that's you can put in your calculator and you end up with this number, okay? And then it's going to be the accumulated value of the investment at the end of 3 years is going to be 575.51. Okay. Any question on this? Okay. Seems everyone is knowing it. What was the accumulated value of the investment at 3? Okay. So if you want to do it in terms of a calculator, okay. So let's do it in the calculator mode. Okay. First of all, you need to turn on your calculator, set second, and clear TVM. Clear TVM is just the FV bottom. On top of it, it said clear TVM. So second and clear TVM. That's what it does is just clear all the number N 1 over I over Y, PV, PMT, and FV. They set all the number to 0. Okay. So second clear TVM. Now you have to set what is N. Okay. You push 3 bottom, just a 3, number 3. And push N button. This automatically is going to set N to 3, okay? And then for I over Y, you push 4.8. We write 4.8 and push I over Y button, okay? Automatically is going to set I over Y to 4.8, okay? And then for M, you push second button and P over Y, which is going to be on top of I over Y. Okay, and then you set 1 and enter, and then you second and CPT, which is quit. Okay, and then for present value, you first write the number 500, and then since this case is investment, you put a negative sign in front of it, and you set PV, push the PV. Okay.
Sir, excuse me.
Do you want me to show it on the camera?
No, how do you like input P over Y? Like how do you there's no setting button for P over Y?
P over Y?
Yeah.
Yeah. So second button, yellow button.
Oh,
yeah.
yellow.
Do you see my camera?
Okay, yeah.
Second button, yeah, second button. And I over Y, and I over Y. Second, I over Y is going to give you P over Y, okay? You see it?
Yes, thank you.
And then the second button and CPT, second button and CPT is going to quit that mode because you need to quit it. You need to set it first and then quit from the mode, from the P over Y mode, okay? So you have to set and then quit from the P over Y mode, and then when you enter to P over Y mode, you just set the P over Y. So P over Y is M, basically, the compounding frequency, okay? It's compounding. P over Y is compounding frequency. P over Y and C over Y are compounding frequency, okay? You set them to 1, because in this case it's 1, because the interest rate is compounded annually. And then you come out, quit, and then you set the PV to minus 500, and the PMT to 0, 0, and PMT. That's the way you set it. You set 0 and then push the PMT button. Okay, and now you go to future value and click CPT and future value, CPT and future value, CPT and future value, and then it's going to give you the new future value. It's going to be 575.1. Okay. So that's how you basically calculate the this in the calculator. Do a little bit of practice here. You will learn very fast. Okay. So n, as I said, n is number of compounding frequency. Is not number of year. Okay. So number of compounding frequency. I over y is interest rate, nominal interest rate, and the p over y is m. Okay. M, which is compounding frequency. PV is present value, and FV is future value. Okay. So this is in terms of table. Okay, so P over Y and C over Y is the same. Whatever you get, whether you put with the C over Y is going to be P over Y. And this is the step by step, basically. 3 M is N is equal to 3. I over Y is 4.8. And don't forget, it's going to be 4 point. It's going to be in percent, right? So it's not. You don't want to convert it to 0.0048, right? So this is just the it's just the in percent. You have to put it in the calculator. You have to put it in percent. Okay, 4.8. Okay, don't forget that. So don't forget that you have to just put it in the percent. You don't want to convert it to the value. Okay, I mean the nominal interest rate, and then the PV. You put it because it was an investment. They have to minus 500. PMT, as I said, you don't care about it. You put 0. We will discuss this in chapter 10 when we discuss the annuity, and then you put the fee FV, and then press CPT, then FV to calculate the FV. Okay. All right. So how much interest? FV minus PV, which is going to be 575 minus 500, it's going to be 75. Okay, interest. All right, so this is another question. I give you a few minutes for this. Easy Go Travel Inc. invested 120,000 in an investment fund at 12% compound quarterly. So you have present value, you have interest rate compounded quarterly, you have nominal interest rate compounded quarterly. You know M for 6 years and 8 months. What was the accumulated value of the investment at the end of the year of the term, like the future value, accumulated value they call it? How much interest was earned over the time period? Okay, I'll give you a few minutes for this. Okay, it's a simple question. Just put those, just do those math. Okay, which we discussed in the class. All right, so let's do it. You get a few answers here. Yes, A is right. So how do we calculate it? So yeah, we have principal value, we have nominal interest rates, and we have compounding frequency, and we have time. So time, it's just very simple. So nominal interest rate, so the periodic interest rate is going to be nominal interest rate divided by compounding frequency. What's the compounding frequency for this? It's 4, right? So quarterly, right? So it's every 3 months. So 4 is compounding frequency. Nominal interest rate, periodic interest rate is going to be, periodic interest rate I is going to be nominal interest rate divided by compounding frequency, which is going to be 0.03. And then you have time, 6 years and 8 months, 6, 8 over 12. Which is going to be 6.666666666, and n is going to be m multiplied by t. N is going to be 4. This compounding frequency multiplied by t, which is 6.666. It's going to be 26.666. And now we have basically the equation. So 120,000 multiplied by 1.1 plus 0.3, which is I, power of 26.666. Okay, so that's very easy in calculator. It's 1.03 power of 26.666. You calculate this and multiply by 120,000. It's going to be 263,000 whatever. So that's going to be the accumulated value of interest, and basically in the calculator also you can do that in calculator. You make sure you put in calculator the n is the number of compounding frequencies, not the year. Okay, it's not the year; it's number of compounding frequency. You have to multiply the number of year by compounding frequency. Okay, number of compounding period. Sorry, number of compounding period. Okay, and then this is nominal, and they said you have to set p over y, c over y at 4, which is compounding frequency. Present value minus 120,000 because it's an investment, and then you press CPT on future value. Okay, it's going to be 142,000 as the investment. Okay. Tiffany's consulting company deposits 65,000 in gross fund at 6% compound semi-annually. After 4 years, the investment rate changed to 4.75% compounded annually. Okay, so first 4 years you have 6% compounded semi-annually, and after 4 years, it changed. The rate of compounding changed to 4.75%. It's the same as the mortgage rate, right? The mortgage rate change every year, right? Every month. Right now it becomes every 2 years, every 2 months. So the mortgage rate change means the whole calculation is going to be changed. Okay, so you have to basically get familiar with this kind of calculation. Okay, so 6% compounded semi-annually for 4 years, and after 4 years become 4.75% compound annually. Okay, what's the value of the fund at the end of 7.5 years? So you have 4 years of this guy and 3.5 years of this guy. Okay, 4 years of that guy for 6% compounded semi-annually, and 3.5 years of compounded annually with 4.75%. So you have 2 questions to solve. Okay, first question: how much is going to be for the first 4 years? Okay, from present value to 4 years, future value for 4 years. Okay, first you have to calculate this, and this future value after 4 years is going to be principal value for the next 3.5 years, right? So basically, you calculate this guy until 4 years, you find the future value for this, and this is going to be the principal value for the next 3.5 years. Okay, that's how we calculate the. That's how we calculate this question. Okay. So first of all, let's construct basically I and n for this period of time, and then construct I and n for this period of time. Okay, I means periodic interest rate, and n means number of compounding periods. Okay, so how do we calculate the I? I is going to be J divided by M. J, what's the J? J is 6% divided by M, which is number of compounding frequency. Semi-annually means 2, so it's 0.03. N is going to be number of year multiplied by component frequency. 4 year by component frequency is going to be 2. It's going to be 8. So this is I and n. For this, you construct it. Then we can put in the equation present value I1 plus I power of n. We calculate the future value for 4 years. Okay. So that's what we can do. And now let's construct for this guy. This is annually, compounded annually, means m is equal to 1. Okay. So this is going to be the same, 4.75%. I got 4.0475. And n is going to be 3.5 years, right? So 3.5 years multiplied by 1 is going to be 3.5. Okay. So now we have I and n for this guy and I and n for this guy, and then put just in the equation. I and n for this guy is going to be this guy. And then we do the equation. So after 4 years, present value is 65,000, and I and n we find the first 4 year. We put in the equation. We find basically the future value for 4 years. It's going to be 82,340, and then basically for the next one. So this future value after 4 years is going to be present value. For the next one, right? So the present value for next one is going to be this guy. This is the interest rate, the periodic interest rate, and also this is the number of compounding periods. So we put that in that equation. We do the calculation, and it's going to be this one. Okay. All right. So next question. Next question. Okay. Okay, James borrowed $15,000 from the bank at 6% compound quarterly. Okay, he repaid $8,000 at the end of first year, and another $3,000 at the end of second year. What amount at the end of the third year will be cleared his loan? Okay, these are a little bit complicated question, but this not too complicated. Okay, so we need to basically 6% compound quarterly, right? So we know we have to. Okay, so what we have to do, we have to find first of all after first year how much is going to be future value of this loan. Okay, so from that future value we have to deduct $8,000. Okay, so that's going to be principal value for the first year from first year to second year. Okay, and then after we calculate after we calculate the first year, after we calculate first year to second year, then for the second year future value, we have to deduct the $3,000. And then again, it's going to be the principal value from second year to third year. Okay, so that's how we calculate this. Okay, so let's find, first of all, let's find I and n. I and n, guys. I and n, the first priority. I and n. I is j divided by m. J is 6%. M is going to be quarterly, which is going to be 4. It's going to be this guy. And m, okay. So that's what I said here. Okay, that's what I said. So you borrow $15,000, future value 1. We find you have to deduct it from minus $8,000, which is going to be present value for 1 year. And then we do this, and then deduct this, and then this. Okay. Okay. So if V1 is going to be based on this I and the number of year, which is going to be 1 multiplied by 4, n is going to be m by 1. M by 1, yes, 1 year. It's going to be 4, right? And it's going to be 4. And then if you find this is going to be future value of 1, right? So you have to deduct this from 8,000. So 8,000 has to be deducted from this guy. It's going to be this one. So this is going to be present value for after 1 year. Okay. So this is going to be the money which you put in the bank after 1 year to get the interest for the second year. Okay. And now for the second year, you have to do the same calculation. You have this number. So we find the future value 2 by PV1 by 1 plus I power n. And we have I, which is going to be this guy. We have n, this is going to be 4 because it's compounding frequency, 4 multiplied by 1 year. Okay. And we calculate this guy. It's going to be 8,400, and you deduct $3,000 from it because it said, and another 2,000 at the end of second year. So you deduct $3,000. It's going to be this guy, 5,406, and this is going to be a present value from second year to third year, right? So, and the third year, you find the future value for the third year. as this. Future value over 30 years, the PV2, present value for the second year. After this guy, and again, the same process, we find this. So at the end of the third year, he has to pay $5,738.24, basically to pay his loans, okay? And you can do it also in calculator, and you have to do that 3 steps. So the step 1 for first year, step 2 for second year, and step 3 for third year, okay? All right, the last question. I think we can also handle this. We have a few minutes. Bahar's consulting company deposits $65,000 in gross fund at 6% compound semi-annually. After 4 years, the interest rate changed to 4.75% compound annually. Okay. What's the value of fund at the end of 7.5 years? So, okay, so this is the same question as before, right? So. Same question as before, and then now you want to do it in terms of calculator. So, so with the calculator, basically you put the number there, and make sure the n is going to be number of compounding period. It's going to be 2, it's 4 years multiplied semi-annually, which is 2, 8. You put the nominal, you put the m, you put the present value, which is going to be 65,000, and after 4 years, you want to know what's going to be future value, 82,000. And this 82,000 is going to be present value for 4 years, and then again you put the number there in the calculator for the 3.5 years of remaining of 7.5 year. In this case is compounded annually, which means compounding frequency is going to be 1. So it's 1 multiplied by 3.5. The n is going to be this. I is 4.75%. P over y, C over y, m is going to be 1. Present value is this guy, but with some negative sign, right? So because it's still investment. So negative sign, and then you find the future value. Future value is 96,861. So it's calculator. If you practice a little bit, the calculator is going to be easy to do that. Okay. So interest rate in the total amount is going to be 96,000 minus 65,000, 31,000. It's going to be interest rate. Okay. All right, guys. So we're done with this. Any question?
Sir, please, is it possible just to explain the last question again?
Say it again.
Is it possible for you to explain the last question again?
You mean this question?
Yes, please.
Oh, this is the same question as this guy, right? So this is the same question as this guy, but we solved it with the calculator. Yeah, here, Tiffany company. The same thing. Tiffany company, but this is the same question as this that we explained it before, right? So the same question as this question is just Bahar instead of Tiffany is Bahar. Okay, the same question. We solve it with hand here, but in that part it's solved with calculator instead of using hand. Okay. Sorry, this one. Use calculator instead of hand. Okay. This is just the same question. The same question which is solved. So $65,000. You put $65,000 at the compound 6% compound semi-annually for 4 years, and then 4.75% annually for 3.5 years. So the total is going to be 7.5 years. So the first 4 years you need to calculate the interest, the accumulated value after 4 years, knowing the principal value and the nominal interest rate, and using the calculator. Okay. So n is going to be the number of compounding frequency, which is going to be the number of compounding period, which is going to be the compounding frequency, which is 2 semi-annually, right? 2 multiplied with 4 years, 8, and then you put the compound basically nominal interest rate 6, and you put the m, which is 2, m, this is m, p over y, c over y, 2, and then the principal value minus $65,000, because this is an investment, right? And then you push CPT and FP, you find the value, okay? And the calculator. And then this value is going to grow again from after 4 years to 7.5 years. So it's going to grow again for with 4.75% compound annually. So compound frequency in this case is 1, right? So 1 and 3.5 years, and they put the number there, and you calculate the final value, okay? And this value, the present value, comes from the future value of the other guy. So this guy, the future value after 4 years is going to be present value for the next 3.5 years remaining. Okay. So this is the same question as that we solved with hand, but now using the calculator instead of hand. Okay.
Okay, I understand.
Any other question, guys? All right, so I recommend to basically, let me just go out of this screen mode and stop sharing. All right, so I recommend you guys to go and do the lab 2, lesson 2, basically in your Vereta, basically the course shell, so that you don't basically lag behind doing the lab lessons, because this stuff is fresh in your mind right now, and it's good to do it lab and lesson when the stuff is fresh in your mind. So before it evaporated, right? So the stuff's come fast and go fast. So you evaporated, just try to go to lab 2 and lesson 2 and those things as well. And if you don't have any other question, we can call it off.
Thank you so much.
Thank you,
All right.
sir.
Professor.
Thank you.
Yeah, you're welcome, guys. I recorded the whole thing also on the Zoom. It's going to be available in the Zoom in a few minutes. Okay.
Professor,
Right,
I missed the last class. I was looking for the recording in the Zoom, but I didn't got the.
Yeah, it's unfortunate I didn't record the last class, so I will make sure that we record from this class. But there are lots of materials online, so there is also in a YouTube video on the same thing. If you go online to Blackboard, you can find on week 1 you go to weekly sessions, and week 1 you see a YouTube video for like an hour and a half of explaining the same thing. So and also you can go to SLG. Study learning group if you have any question there as well, which I send the link to you guys in an announcement. So I make sure from this week I'm just gonna I will record everything. Okay. So sorry, last week I was not there. So I presume that Zoom is going to be automatically recorded. I didn't know that I have to push the record button to be able to record it. I thought that Zoom is automatically. When I said in the option in Zoom that automatically record, I thought Zoom is going to be automatically record that. I didn't know that I have to push the record button here. Okay, so that was my fault, but I will make sure that's not going to happen anymore. Okay. Okay. Any other question?
No question. Thank you. Bye bye.
All right. Thank you. All right. Bye.
So, Professor.